Hi guys, welcome to my channel. I'll be showing you guys this awesome stuff today. You'll be designing a power supply or rectification system without a transformer. Now, this is the major component used in the design of the rectification system without a transformer. I'll be showing you guys this capacitor. It's very common. It's called Pcc Capacitor, and you could actually use it to design a voltage rectification system that could produce 12 volts, 5 volts, down to even 15 volts, up to 15 volts. So now let me explain briefly from the circuit I designed previously in the class. This is 220 volt 50 Hz AC supply sent to a 100k resistor to reduce or resist the amount of voltage coming to the 1 mega ohms resistor, then down to the Pcc capacitor of 2.2 microfarad. Then we have an output voltage of about 40 or 30 volts, which will be sent to the bridge rectifier, which will be suitable for the bridge rectifier to start rectification with. Then we'll have our AC and we'll have our positive and negative terminals producing it. And this capacitor here will be for filtration, this is for limiting AC ripples, and this is voltage backward. So now this is voltage regulator, and this is a digital multimeter. So let's get to start designing our own circuit. But before that, please, if you are a new member to the channel, don't forget to subscribe to this channel. We'll be showing you more some electronic inventions and circuits for you guys to use. So let's get started. Now, the first thing I need to do, I'll be starting something new, entirely a new page. So now we'll be needing an AC supply, because we'll be converting the use of a rectifier is to convert or AC into DC voltages. So I'll be needing a bridge rectifier, diode, you could name it, AC supply, resistors, capacitors. So I get my passive component. I need 3 resistors. So this is my 3 resistors. Now the next thing I'll be needing is a ceramic capacitor and an electrolytic capacitor. So I'll be using, in this case I'll be using a voltmeter or a digital multimeter as my output component to display the voltage, an ammeter to show us the current of the circuit, current rating of the circuit, then an oscilloscope to show us the signal form, how it will look like before and after the rectification. So I think that's all I need for now. So let me take this up here. So when designing yours, shouldn't fail to put switches and fuse for protection. I'm just doing this for practical classes. When I'm designing physically, there'll be a fuse and there'll be a switch. So, but now I'll be changing this to my AC supply to 220 volts 50 Hz. So 220 volts 50 Hz. Then the next I'll be connecting is my 100k resistor, which will be my R1. I'll be changing to 100k resistor. The next will be my R2, which will be 1 mega ohms resistor. So I'll change this to 100k, my R1 to 100k, and I'll make it 2 watts. You could decide to make yours 1 watt, depending on the one you could get in the market, but a minimum of 1 watt to withstand AC voltage. So make it 1 full watt, 1 watt. So I'll be making it 100k resist, 100 kilo ohms, connected in series to my live terminal of my AC supply. Then I'll be connecting my ceramic capacitor. I'll be converting it to 2.2 microfarad, which is equivalent to 105 or so. So I'll be connecting it in a shunt point. So let me take it backward a little to the circuit, then connecting my mega ohms resistor in series to the 100k resistor. So our R2 will be connected in series to 100k resistor, which is 1 mega ohms resistor. Then the next now I'll be connecting is my bridge rectifier. Now for you to see a bridge rectifier, let me zoom a little on this bridge rectifier for us. Now if you notice, if you should not have noticed that a bridge rectifier has sections. Now in the bridge rectifier, there is, if you could see below here, you could now see this area here is a bridge rectifier involves 4 diodes. Now these 4 diodes are connected in 4 segments or 4 sections. This section is where you connect your AC. It's called pin 1, because why you could be able to connect an AC is that the diode negative terminal and the positive terminal are joined together at a junction. At this second point here, the same thing happens. It's like you bring a negative of one diode and a positive of one diode and join them at this juncture, creating. So, and in our live wire, a live and neutral circuit, we have positive components and negative component, or negative electrons or charges. Now the positive charges that will get through from our live terminal from here will go through this diode 1, but they will only escape through this direction, because this diode is connected in the part where the positive terminal only allows positive charges to come out, while the next terminal, the next section, it returns back and it will go into this diode, but only negative charges are allowed to leave this diode. So we have negative charges at this place, creating a negative and positive, which is a direct current pattern. Instead of a sinusoidal we have in our AC alternating current, we have negative charge DC and positive charge DC. So you can see pin 2 negative DC, pin 4 positive DC. So the same thing happens here. When the neutral positive component and negative component comes from the neutral, they go in here, just positive goes through and the negative returns back and negative goes through here, so creating a direct path. So the use of a diode is to allow charges to move in one direction, in a single direction path. So that's what they use basically for rectification. So now the next thing, I'll be connecting it to my circuit, my resistor and the Pcc capacitor circuit. Then I'll be connecting this negative terminal down to the neutral terminal of our AC component. So good. Now the next I need is I've created a positive and negative section. So I'll be changing this capacitor value to 470 microfarad. You could use 470 50 volts or 470 400 volts. It's more advisable to use a 400 volt. It's safer at that section. So I'll be connecting the positive terminal of the capacitor to the positive terminal of my bridge rectifier. So this is it. Now the next I'll be connecting is my negative terminal of the capacitor to the negative terminal of my bridge rectifier. And the next I will be doing is I need this resistor to be connected in series. Now this resistor is actually designed to be 1 watt. It's designed actually to reduce or resist the escaped AC ripples from the capacitor. So I'll be making it 220 ohms. It's a very little resistor. You can make it 1k ohms, but equivalent or better still 220 ohms resistor. So the next thing I'll be doing is my diode. So this diode will be used to prevent voltage to flow in 2 directions. So the output goes out and nothing comes in from that direction of the circuit. So this is it. I'm connecting it in parallel to my circuit. Then I'll be grounding my circuit. So you could actually, for grounding of your circuit, you just get a metal or a metallic part, connect this section or the neutral terminals to it. So you ground your circuit. So we have ground and Vcc now. So the next thing I need is my voltage regulator. So I'll be getting my voltage regulator from my gallery Now the voltage regulator, I'll need 12 volts, so I'll be using 7812. The 7812 stands for 12 volts, 7805 stands for 5 volts. So this is it. So this is my circuit. Then now in a voltage regulator there are 3 pins. The pin 1, 2 and 3. The pin 1 is input, the pin 2 is the neutral or the reference, which is ground, which is the middle pin. So that's where you connect your ground circuit, and your output also grounds to that section. Then your output of the voltage regulator is what gives you the actual voltage you need. So I'll be connecting my pin 3 down to my voltmeter to give me a reading of the volts we've designed to give us 12 volts. Then I'll be connecting my ammeter in series to my circuit. Now the ammeter will be connected in series, but will be connected before, that's once after the voltage regulator and the bridge rectifier, then before the pin 1 of the voltage regulator. So this should be giving us the arms of the circuit. So let's stimulate before we start drawing the signal form. So we have 12 volts from our voltage point. We have 12 volts DC, and sorry, let me check my arms. So I need to change this to arm current. So good. Now I have 1.5 or so 6 amps, 5 6 here, or 6 7 amps for the circuits. So good, our circuit is good and ready to be used. So the next thing I'll be showing is I'll be explaining how my rectification happened. So I'll be connecting the channel 1 of my, I'll be showing you the signal form through a graph. So I'll be showing you now, this is my oscillator, my oscilloscope, sorry, not oscillator, oscilloscope. So I'll be connecting my channel 1 of the oscillator positive pin to the 220 supply, then the negative terminal of the channel 1 to the neutral of my 220 volt supply. So then the next I'll be connecting is my channel 2. I'll be connecting the positive terminal to the pin 3 of my voltage regulator, where my positive charges are found, where my DC charge is found. So then the pin 2, I'll be connecting it to ground. I think that's good. So let's get to draw the graph. Let's get to draw the graph. So this is my actual circuit. So I'll be drawing a graph here. So I'll be changing. For us to stimulate, I need this to be in, let's get red now. Okay. So 350. Let me get my graph ready. So good. I think this should be okay. So let's stimulate and test. So we have our this section shows. Now you could see there is an alternating sign, which is signal generated from the channel 1, which is our AC section, where the sinusoidal waveform is generated, while I'll be showing you guys in dark view so you'll be able to get it good. You could actually see the white line underneath here, which is the DC supply. So I can change this to some other color, maybe that's be better. Let's use something darker. now what we have. So this is our signal generated. So below here, so I'll zoom in a little on the graph. So if you could see, there is a second line here which starts at 12 volts. This line, so this is green, is a 12 volt. It means 12 volts generated DC, while the sinusoidal waveform we have is the AC from channel 1. So we're done with our rectification system, transformerless rectification system. So I'll be converting it to PCB for you guys to see my circuit in Pcb View. Yes, so this is my Pcb View. Sorry, it converts. So please don't forget to hit the subscribe button. Yeah, we're done. So let's check this. So this is how our Pcb View of this circuit will look. Wow, isn't that, it's looking beautiful and great. So we've been able to design a full wave rectification system without a transformer. So thank you for watching the video, and don't forget to hit the subscribe button to get more awesome videos on this channel. Thank you very much.